Intro to Engineering Design. This is Instructions 4, Activity 5.2a, Geometric Constraints. So we are on November 10th, and your activity for today, just a one-day activity, is to learn a little bit about some constraining tools inside of Inventor that help us control the drawings that we're working on. So to get started, we can go ahead and click on the link to the assignment, and in Schoology, that'll open you up to your activity. Let's go ahead and go there, I guess. And once you are there, turn this off. We can read through the procedure here. You'll open the file called Geometric Constraints from your Inventor work folder in your Google Drive. Read the instructions above each image in the file and use the Geometric Constraints tool to complete each of the 12 exercises. Your completed sheet should look similar to the one pictured on the activity sheet. All right, this is all on the activity sheet, so I'm going to go right to that activity sheet and walk you through it from that perspective. All right, so your intro, I like to always read through this with you to make sure we're on the same page. I'll try and make that a little bit larger so it's easier to see. There we go. And this is going to be important. You'll have some conclusion questions to answer, and those are going to come to a great extent right out of this area. If you can't find it there, you may have to do a little bit of work on your own, perhaps a Google search to learn a little bit more about constraints. So, a CAD model can quickly display an engineer's ideas in a realistic way, and those models can be used to generate technical drawings that can communicate the information necessary to make the idea a reality. In order to generate a 3D model, designs must start with sketches that are generated within a 3D CAD program, such as Inventor. These computer-generated sketches will appear to resemble hand-drawn sketches in geometry, in other words, the combination of points, lines, and shapes, but have big advantages over hand-drawn sketches. One important difference between a freehand sketch and a CAD sketch is accuracy. The lines of a CAD sketch can be drawn perfectly straight, with start and end points that occur in exact locations in space. And by using numeric dimensional constraints, a line may also be given precise length, placed at a specific distance from another sketch or feature, or constrained to be oriented at a specific angle from another straight line. By applying geometric constraints, a line can be made perfectly horizontal or vertical. If more than one line is being sketched, they can be made perfectly parallel or perpendicular or even collinear or equal in lengths. Lines can be constrained to be tangent to circles or arcs, and two circles can be constrained to be concentric. In order to precisely model a part, the designer must be able to use both dimensional and geometric constraints within a CAD program. You have already used linear dimensioning in earlier activities, and in this activity you will learn about geometric constraints that are common to most CAD programs and practice applying these constraints in CAD sketches. So you'll be using, of course, your computer or Chromebook and some CAD files or a CAD file to work with this. So the procedure, you are going to open the file called Copy of 5.2 Constraints from your Inventor work folder in your Google Drive, read the instructions, and then complete the activities. You'll make the geographic constraints visible by choosing the Show Constraints tool in the constraint. To be honest, I don't use that. I think you can do this without. And you're also going to add your name to the bottom right corner that you may then use the text tool. So about 13 steps you're going to do on this sheet. So the long and short of it all, you're going to find this file in your Google folder, and you're going to make it so it looks like that. Okay. When you're done, make sure you go and do the conclusion questions, another 15 points there, and I'll talk you through some of that from the intro. What's a geometric constraint? And then you'll learn a bit more. If you don't remember what a tangent is, you may have to look that up. And then make sure you give me a complete answer. How is a geometric constraint different from a numeric constraint? Okay. be clear on that. A lot of people miss that one by not comparing the two, okay? Make sure you're comparing the two. All right, so let's go ahead and jump into Inventor from the web streaming service. I'll go ahead and get this open on my screen. And once this is open, I'll show you how this activity works. I'm going to go ahead and go full screen. And there we go. We're up and we're full screen. So what you're going to do is go open, of course, like we've been doing. Go find your Google Drive. So here's my Google Drive and my drive. Let that populate or load. Okay, so it looks like it's coming slowly. There it comes. All right, we're going to find our IED folder. I have a few more folders than you, so it takes me a little bit longer. I'm in IED 2021, and inside of there, I should have my Inventor Work 2020. What you're looking for is this one right here, copy of 5.2A SR geometric constraints, something of that nature. 5.2, I think yours might be simple, copy of 5.2 constraints. Double click to open it, and that should open up the file in your Inventor program and allow you to begin working with it. Couple steps on this to make this workable. Here is your file. Let me get my picture out of the way. And all right, so to make this workable, what you need to do, and this is in the instructions as well, you need to come right over here to where it says Sketch 1. And if I right click and I go Edit, it should put me in edit mode, and we can tell that because the green check mark is on. And you're just going to walk your way through each of these. Part of this exercise is becoming familiar with the constrain tools, okay? So it says make perpendicular. I want this line perpendicular to this. So to find that, I'm going to let you explore, but I'll show you the first one. So I'll go up here, and if you hover over each one of these, it tells you what we're really curious about is these right here. Keep in mind that these are geometric constraints. We also have a numerical or a dimensional constraint tool right there. For today, we're focusing on these, about 12 sets of constraining tools. So I want that perpendicular. So usually you're going to use these and find out what they are. For example, there is coincident constraint. You'll have to read about that a little bit. But if I want perpendicular, I come up here. It says perpendicular constraint. I click on that to turn that tool on. Click on one line, then the other. Just like that, my lines are perpendicular. Right click, and I can cancel to turn that tool off. You'll work your way through all 12 examples here. Then, when you are all done, you need to add your name to this file. So we can stay right within the sketch mode, and we can use the text tool. And we can come right down here near the bottom, put that in. I want you to change the size of your text tool, though, because it's pretty small. We're going to change that to 0.24. So just key in 0.24, and we can go ahead in this box, write in our name, and we hit OK. Just like that, your name then appears on your drawing. We can hit right click and OK to cancel that. I can move that if I need to get it into place, but there are 12 steps plus putting your name. So it's 13 steps that you need to do. A second part of the activity, and I'm going to minimize this so I can bounce back to the activity sheet, says using Inventor, describe what each of the highlighted constrained tools are and what they do. Define them in order, reading from left to right, top row to bottom row. So you'll start here, so left to right, left to right, left to right. Just those that are highlighted. So for example, the first one, what is that? Okay, we need to jump back into our Inventor model, and you have to be in sketch mode for these to be live. So we come back here, that says coincident constraint. So to answer that one correctly, you would type in the word coincident constraint, then our definition is right below that. So if I read that, it says coincident points to other geometries in 2D or 3D sketches. And basically, what I want you to do is a point coincident with the curve can slide or lie anywhere. So that information in that box is what we're going to put in there. If I slide over here to collinear, okay, you can just take that first part of the definition. So collinear, in this case, our definition causes two or more line segments or ellipse axes to lie on the same line. So there's the word followed by the definition. That's what you'll be doing in this portion of the activity. I believe there are 11. So you're going to give me 11 answers here. Okay, if you'd like to just put the name in bold and the rest in lowercase or non-bolded text so I can easily identify them, answer the questions, and then submit. To add your completed drawing, I did put a note here. Insert a snip of your completed geometric constraint file right here. So you'll take a snip of your work and then you insert it right there, and then you can submit the drawing. So this will help us learn a little bit about some more tools inside of Inventor that make this a pretty powerful tool to work with. So that's our activity for today, activity 5.2a, geometric constraints.